So welcome everyone back to the last session of DB Test. And for this session, we invited 4 industry experts to chat with us about different perspectives on database testing and benchmarking, as well as the challenges that are involved from an industry perspective. I guess you already saw that we posted some questions both in the Slack and the Zoom chat. So these are the main questions on which the discussion will center on, but perhaps also some new directions will come either from the audience or from the experts. And with that, I guess we can directly dive into it and start with a self-introduction by every panelist. So let's perhaps start with those that are joining virtually. Abdul, do you want to go first?
Yeah, sure. Thanks. Thanks for the opportunity for being on the panel. So I'll briefly introduce myself. I'm a research scientist with IBM, and I've been working with IBM research for the past over 6 years. And primarily, I have been working on using at the intersection of data and AI, and using AI techniques to provide better data management solutions. I've had experiences with building natural language interfaces to data and conversational systems. And with regard to this panel, I can sort of give an insight into the testing for generation of SQL queries, starting from natural language interfaces and those kind of challenges. So that would be very interesting.
Okay, thanks, Abdul. Next is Tiati, and here I first have to mention, so Tiati agreed on a very short notice to be on the panel, so thanks a lot for that, because Allison Lee, which I announced in the morning, unfortunately couldn't make it, so thanks Tiati, and perhaps could you introduce yourself, please?
Hey, I go by Jackie, by the way, so
yes.
I can just call me that. So yeah, hi everyone, I'm a software engineer at Snowflake. I've been with Snowflake for almost 7 years now. These days I mostly work on the query engine, query optimizer, compiler, workflow optimization features, infrastructure and other toolings for the query engine as well, including testing systems and so on. Related to this discussion, I've helped build a number of testing infrastructure for Snowflake, and interested in kind of discussing with other panelists regarding the production, looking at the testing system from a production perspective. Thank you.
Okay, thanks, Jackie. Then I think we can continue with Greg, who is already holding the microphone. So could you please introduce yourself?
Yeah, hi, I'm Greg. I am co-founder and CEO at Undo. We are the time travel debugging company for Linux. So we allow software developers to see exactly what their software did line by line. They can step, like in a debugger, but step backwards and forwards and see every single line of code that executed. So I'm not a database company, but a lot of our customers are database companies, and particularly gets used a lot inside the test and QA areas in those database companies. And I think a lot of the challenges that we face, just like testing our own code, actually has a lot in common with the challenges of testing databases.
Cool. Yeah, I'm Yingjun, and I'm currently running the company called Synchronous Data, and we are doing database systems, and we're basically building a new cloud native streaming database system. Seems that we can be your customer, right? Yeah, cool. And before I started this company, well, I was at AWS Redshift, okay, our competitor to Snowflake, okay. And and before joining AWS Redshift, I was with IBM Research Armadan. I was actually ex-colleague with Abdul and Pinar. And I obtained my PhD from NUS, and Manu will be joining NUS. And I was also visiting PhD at Carnegie Mellon University with Andy Pablo. Yeah, that's my.
Okay, thanks, Yingjun. Great. So the first question that we wanted to discuss is what are the common things people tend to ignore or oversimplify when building a testing or benchmarking framework? Does anyone want to take this question? I'll start with it.
Yeah, so I think I describe it as they forget all the nines in that sort of how many nines reliability you need for testing at scale to work well, right? So we're all doing, continuous integration and testing, elastic compute resource to do all our testing, and even a moderately, averagely sized software project these days is probably running tens, hundreds of thousands of tests every hour, maybe more, right? Individual tests that get kicked off every time somebody submits a pull request or whatever. And so if even, you just do some simple arithmetic. If even if 99% of those tests are completely reliable, and of the remaining 1%, they're all like 99% reliable, that still ends up being a lot of flaky failed tests every hour, right? And that's, so you just have to be completely solid. And that flakiness comes from lots of different sources. I think often from insufficiently resourced test infrastructure. And so I think you then get this kind of situation where the developers stop trusting the tests essentially. And I've seen this a lot. I mean, we used to have it in my own company, and I've seen it a lot with customers where people get in the habit of, if the tests fail, like you got some CI tests that run, when you submit your pull request and you get a failure, I hit rerun. I just got unlucky. I'm just going to rerun those tests and see if I get green next time. And once that starts to become your habit, or even worse, when you start making the system do that for you, then you get into just a lot of trouble, because you just get all this more and more flakiness building up. And I just see that all the time now.
Yeah, so at Singularity Data, we have all kinds of test cases. We have the unit test cases, we have the functionality test, we have the API test, upgrade test, downgrade test, for migration test, for all kinds of test cases. And what I found is that most of the companies will, at least for open source projects, in open source projects that do not really take test cases seriously, and they assume that they are running in a very ideal environment, which is like, okay, you have a dedicated machine and you can nothing fails, right? And you have a perfect hardware, and but in reality, the thing is quite different. Like in Redshift, or if you have a RDB database, or if you're building an OLAP database, you will have a concurrent queries. Basically, you have multiple users issuing their queries at the same time, right? And you will be easily run on memory. So definitely, test will be a test case, kind of test case that people may ignore. And the other one is that with stress test. Yeah, similar to test. Well, okay, stress test is like, okay, so for us, when we're doing stream processing, it's like, okay, we probably need to run stream processing job for a day or separate day to ensure that, okay, the correctness. And some other thing is like, okay, the instance types. So in AWS, we have all kinds of instance types. We have the Intel machine, right? So we have the Intel CPU, we have the ARM CPU, and there are different regions. There are machines in different regions, different size, right? And sometimes we will find that, okay, in some cases, okay, we can pass a test in certain kind of instance machine, but the test case can fail in some other instances. So people will just test against a single type of machine. But in reality, probably you have to test all kinds of machines to ensure that you can pass test cases. Yeah, in all these kinds of instance types. Yeah.
Do you get like a cross-product problem there, though? All your different tests on all the different kinds of machines, it gets very expensive.
Yeah, actually, okay, so in Redshift we have, okay, I cannot speak for Redshift, but in our company we at least we test the Intel and ARM chip. And we will choose a fixed number of instance types so that we can ensure that, okay, we don't really want to test all kinds of test cases. Otherwise it would be too expensive. Yeah, definitely the test cases, testing, the CI/CD can be very expensive. So we use spot instance to reduce the cost. Yeah.
So I can talk a little bit about the problems I see in our company related to this topic. First, I want to echo Greg's comment regarding the stability of the testing framework. It's super important, and it's a very, very hard problem, essentially keeping the master or the main green at scale when you have like 1,000 developers working on the same code base and making changes at the same time. This not only means the resource allocation for your CI/CD pipeline, it also means the testing framework needs to be able to be resilient to certain way of writing tests that could be generating flaky results. There are also other testing framework, pretty common ideas that people have, right? For example, merge train is a good mechanism to kind of ensure at least the stability of the test in the main pipeline. And but overall, I would say this is always an ongoing effort that requires help from both the test writers, developers writing tests. They need to make sure they don't write flaky tests, as well as the infrastructure. So this is one aspect. The other aspect is the speed of the testing system, right? So when a developer submits a kind of what we call pre-commit test to kind of get the kind of sanity check of their changes, it's going to be a lot of it's gonna incur a lot of context switching costs if the test takes many hours to run and come back, and the developer might need to kind of switch to work on something else, which not only means switching in terms of their builds, but also means switching in terms of their context, right? So the speed of a testing system is also very important. That means, what do we test for before we allow the change to be merged in? And once the change is merged in, how do we expand the set of tests to be run to have a wider coverage, and how soon do we need this coverage? So at different stage of the testing pipeline, it's a test selection problem essentially regarding, how do you, what kind of test do you run at each of the stage to kind of ensure this balance between the speed of a test as well as the coverage of the test at that stage, because you also want to kind of discover issues earlier. The other thing that I see is with the extensibility of the framework, especially in larger organizations, there tend to be many different people tend to write many different frameworks to do very similar things. I would say, especially with performance testing, because someone tend to need something that's slightly different from a performance testing perspective from someone else, right? Someone wants to use JMeter, someone else wants to run their own Python script, someone else want to do something else. And the extensibility of the testing framework to cover different use cases is very important, but it's also very hard to achieve. What I've seen that we haven't done very well is whenever someone tries to build a new framework, they end up building yet another framework. And then I think there are also other small things that tend to be ignored by kind of testing systems when they are initially built. For example, if you have a kind of a fuzz testing query generator, how do you test for things like non-deterministic queries, which is about 40–50% of all the queries in production. So that these are very important aspects to be aware of when building a testing framework.
Thanks.
Yeah, great. Thanks for all these inputs. I would like to also add a different perspective to database testing, and try to tell you a little bit more about my experience with text to SQL systems that are becoming more popular as they allow the democratization of access to data and insights to a much wider range of personas. Business and non-technical users are the actual users of these insights. And so these text to SQL systems are trying to bridge the gap between the people who will consume insights and the actual database systems which are going to generate those insights. Now, as you have seen and heard from the other panelists, database testing has been there for a very large number of years, and there have been a lot of different benchmarks and traditional old benchmarks, testing for OLAP queries or OLTP queries, and different benchmarks testing different forms of these queries, both in terms of performance as well as the ability to generate these queries with accuracy for all these different end-to-end benchmark systems. So unfortunately, since the text to SQL systems is something new, so we don't have, let's say, very established traditional benchmarks in these areas, and this is like an area which is growing up, and there are a few benchmarks that have come up which try to train models using natural language queries and SQL pairs, and then the benchmark just gives you these pairs and would require your system to test whether, given a natural language query, could you actually generate a particular SQL query and run it against the system. So there are two aspects or dimensions to it. Not only is the accuracy of generating the appropriate SQL query important, but also, in the end, it's also the performance which matters. The performance in terms of interpretation of the query and then actually executing over a database system. So what are the things people like in practice that have seen that would ignore for testing these kind of systems? One is in terms of complexity of the queries, right? So there are two places of complexity. What are the kind of natural language questions that you could answer, and what are the kind of SQL queries that you could actually generate? So a lot of systems, when these benchmark systems, when they create these queries, somehow there is like an oversimplification in terms of what is the natural language question and the SQL query that can be generated, which sort of limits the applicability to these systems to very simple use cases, right? And so there is a need for systems to actually comprehend more complex natural language questions, as well as the ability to generate complex nested queries lists. So for example, to answer, let's say, BI questions and analysis, right? The second aspect in terms of complexity is, which people usually ignore in these systems, is that they consider pairs of questions as well as tables that you need to generate these queries against, and they simplify this, remove joins, let's say, for example, across multiple tables, which again limits the ability of these systems to generate comprehensive queries across many tables, which in reality would actually be the need in these systems. And the third thing people often ignore while training their systems is transferability of your model to generate these queries across different domains, right? So if, let's say, that you were trying to generate a BI query against insurance data, which relates to your medical payments, is a different domain as opposed to generating a SQL query against the finance domain. And so trying to test your system against a set of databases, schemas, which all correspond to different domains, is another dimension of complexity in testing. And often all these three different areas are being tested by systems which only, like, some of them are concentrating over domain, some are concentrating over the complexity, but we still do not have, let's say, a unified sort of a benchmark which could actually go across all of these different dimensions and test a system more comprehensively.
Yeah, thank you very much to everyone. And by the way, hi, sorry that I was a bit late. Yeah, so are there any follow-ups to what each other said, or are there any questions about as a follow-up to this discussion in the room? Or
yeah, so maybe, if I may, I would actually start with a follow-up on Greg's comments. For me, the question was, like, I really like this idea of robustness and the 99s or the 9s, and I'm wondering, like, what's enough, right? Is there something, because in testing it seems to me that it's really hard to say that, okay, I need 9.999 or 5 nines or whatever? Or is there something that you like based on your experience can say that you don't need 100%, but this will be enough?
I think it's 100%. It's honestly, I mean, I know that in practice that's impossible, but you have to be striving for that. One of the things we learned, so we had a big problem 2-3 years ago with flakiness in the test suite. And my sense was we were getting close to that kind of event horizon where if we get any more flakiness, it's going to be impossible to claw this back, because it's just going to exponentially get more and more. And so one of the things we did was to sort of identify these anti-patterns in the tests that just kept on causing us problems. So for example, whenever somebody had a sleep, any kind of time-bounded thing, a sleep or a timeout, like that just became, no, you can't have that. You've got to find another way to do it, because eventually, you're running on a VM in AWS or wherever, and then it gets migrated, to another node, and your sleep that should have been fine, and the system starts thrashing on the disk at the same time, and your sleep that should have been plenty of time, there's no time that is going to be enough time, and have your test run at reasonable speed, right? So that's just one example of, if there's any theoretical, oh yeah, but that's not going to happen, when you're running millions of tests every hour, it'll happen.
Okay.
Thanks. Any other questions?
Yes, there's one more in the audience.
It was just that when you now said sleep is not allowed on the client, how do you then solve it? Because if you have other processes, you have to start up and you have to wait for them. So
you need those other processes to somehow notify when they're ready, right? So you need some kind of semaphore or whatever. That's how you need to do that. But related to the time thing, I wanted to follow up with Jackie on because this
is like exactly the same problem that we have as well. And the way we solve it is exactly like you mentioned. You need a way for the processes to communicate with each other, and using semaphore, or we use watches and other type of things to essentially get rid of the non-determinism. Never use any sort of hard-coded sleep or timeouts and these type of things. Yeah.
And then that brings us, I think, nicely back to the point that you made about the responsiveness of the test suite, because you could make the sleeps long enough by making them all be like an hour, right? But then everything would take forever to run. So what I was just interested by your comment on you need the kind of pre-commit kind of sanity tests to be quick, and what's good? What does good look like for you?
So I would say we're still pretty far from it, but like my personal goal, or at least our goal, is to get it to below 5 minutes, ideally, for someone to write a test, essentially as kind of a merge gate before I can merge. This is the basic set of sanity tests. And if your test suite is parallelized enough, and each test are kind of atomic enough, right? Then it's just a matter of resource allocation. What's tricky is sometimes you have these single tests that run for a very long time, and that could be problematic. Yeah.
So 5 minutes being maybe enough time to make a cup of coffee, but not enough time to go and start something else.
Yeah. Yes. Yeah. So I want to add one more thing, which is kind of a little bit unrelated to like the testing itself, but I think it's really, really very important as well. It is, especially now in the cloud environments, testing is not really the end of the story, and a lot of issues are not going to be caught by testing, despite our best effort. So having metrics, monitoring of the system, including integrity checks, both online and offline checks, these are also very, very important. And this can also go back and tell us what to focus on in our testing, because there's so many things that can be tested. There's no end to kind of how much tests you can write, right? Because there's always more tests that can be added. So this is also a very, very important aspect for us. And now we have the luxury to, actually look at all these metrics. because we're running the database as a service.
Great. Are there more follow-ups, or should we move on to maybe the second question?
I guess we can move on.
Okay. So the second question is, how can we create a testing benchmarking framework that abstracts away most of the hardware and application complexity of a real-world run, but still effective in discovering bugs or reasoning about real-world performance? And I guess like the inspiration for this was that, like, considering all the standardized benchmarks, like we like to use them as researchers as a proof of concept, or industry also uses them, but they always get this criticism of not reflecting reality. So like, but we still need some benchmarks. So how can we get a better balance between reality and these type of benchmarks? And yeah, anybody wants to go first?
I mean, I can take a crack at it, but I don't think I have a very good answer. I think this is a very hard problem. Even though for us, we have a lot of visibility into real world production workload, we don't have a very good way of today. We don't have a very good way of capturing these workloads and incorporating them as internal benchmarks. Workload simplification, workload reproduction, how to kind of be able to capture the essence of the workload without capturing the customer's data and all that. It is a very, very tricky thing to do automatically, and some sort of manual operator is always needed when someone go and actually study the customer's workload and understand what they're doing, and then they will be able to kind of bring it back and write a benchmark that's similar to that. But it's always a kind of a pretty manual process, I would say, at least for us. The one thing that we've kind of done that's worked around the problem is a framework that we call Snowtrail, and it kind of flips the problem on its head. And the idea there is to actually implement a framework that tests directly on production data, right? So, if you have a decoupled storage and compute environment, essentially what you can do is deploy the new version of the code that you'd like to test in production and replay some of the queries directly on that new version. And because this is completely decoupled from the compute resource the customer is using, this is completely happen transparently in the background. And this is a very, very powerful approach. And this is because we're testing on exactly the same queries the customer will be running, and we would know exactly what the problem would be. But yeah, I imagine this is pretty hard to do unless you have the kind of infrastructure that we have in our database system. I would say one last thing, which is we are still actively working on this capability of capturing workloads and trying to kind of bring it locally. And at some point, I think the workload information that we have internally is a very interesting source of information for academia as well. And I do hope we get to a point where we can talk about some of these things, but we're not quite there yet.
Yeah, maybe actually, yeah. I used to be a researcher, and I published a lot of papers, and after that, where I did a lot of building real world database systems. And what I found is that in many cases, where the benchmarks the researchers are run actually too small. I mean, they did. For example, in the OLAP databases systems, we have the TPCH benchmark, right? Usually, the researcher will set a scale factor to a very small number. maybe 0 gigabytes, right? So 30 gigabytes, 100 gigabytes. But in real world, you should definitely set a scale factor to a very large number. For example, probably 1 terabyte or 10 terabyte or even 100 terabyte. So if you check the Databricks benchmark against the Snowflake, I think that's 100 terabyte, right? So that's kind of realistic. I mean, I cannot say that okay, all the customers are running a database that contains 100 terabyte data, but it's quite common to have, let's say, 1 terabyte data for a data warehouse. And the other thing is that okay, so we actually profile at the runtime, we actually profile the customer's workload. For example, we will check if we run a OLTP workload or lab workload. Then what we do is actually, okay, we will definitely check what the number of columns the query can access and what the predicates look like and what's the selectivity. And we use the numbers collected at the runtime to mimic a workload and to create a workload that can be run for benchmarking purpose. So that's okay. You can use this kind of benchmark to measure performance and see whether we can improve the performance by tuning some knobs or doing some optimizations. Yeah, that's the thing we did. Yeah.
I mean, I think in academia, even 100 gigabyte is not, like size-wise, even most people don't get there. I think even that's rare. But anyway, go ahead, Greg.
Yeah, I mean, I think you have this isn't just about in databases, this is across the industry. There's a problem with when you have standardized benchmarks, what you get is databases and CPUs and other things that run these benchmarks really well. And people there's just a huge incentive to just put lots of effort into just optimizing for these standard benchmarks. So that's always going to be a hard problem to solve. I don't think it's just a question of the benchmarks being big enough, but they need to be, I suppose, varied enough. I think it's interesting. I latched on to what Jackie was saying about capturing real world data and replaying that. Partly because that's something, it's a sort of an area that's close to my heart. That's kind of what we do is capture the inputs to the program as it's running. But also it's something, I see that happening a lot among our customers. Often actually with trying to, not so much benchmarking, but trying to regression test things, right? They know a certain pattern of network traffic caused a problem. Well, let's just replay that and make sure we don't regress against that. But it's difficult for those tend to be things that are run internally by companies and not published into the public domain for researchers to use. So if there was some way to encourage publication of these real world query patterns and network traffic and things, I think that would be valuable.
Yeah, actually, I think a big problem is that the companies usually do not want to share the real world workload, right? And definitely we can not share the user data, but even some metrics a lot of companies do not share, like number of columns the data the data set has, right? A table have, or let's say the user query patterns, right? Whether there's joins, whether there are equal joins, whether there are auto joins. Nobody will share that, but I feel that probably someone can at least share some of the workload, so that the researchers can get a sense of the real world user workload. Yeah.
So maybe let me comment here, because DB test, actually there was a paper 2 sessions ago or 2 years ago, so it's basically 4 years ago, I guess, on exactly that. So basically Tableau, I think, had a paper that showed exactly what kind of what the SQL queries are made of, not like the real workload, but the metadata on the workloads.
Yeah, we definitely need the metadata. Yes. Yeah.
So there's something, at least, and this is like in DB test we can find this.
Yeah, that's cool. Yeah.
I would also like to extend and add my thoughts on what Jackie said regarding collection of real world queries or workload against the database systems, but with a perspective on text to SQL systems, right? So since these are new, collecting real world workloads for such systems is actually very challenging. And the contrast with SQL-based benchmarks is that when you specify a query in SQL, you're very specific of what you need against the system, as opposed to having this another indirection layer where you have the inherent ambiguity in natural language questions. So there are many different ways of expressing the same question, which will actually translate to the same SQL query. So you need to take the variation in the how real world business users would actually express that that query. So getting those real world variations has been a challenge for these real world workloads, as well as the fact that you can actually fetch the same result from your database by specifying the query using like two different SQL queries could actually get you back the right. So that's another aspect in real world that, you know, when you're designing these benchmarks, these are not as standard as your TPCC or TPCH benchmarks that you have a given query, right? So there are multiple ways of expressing the same thing using different SQL queries. And the third thing that's emerging in real world is that people do not want to express complex natural language questions in one go. So people are moving towards conversation. As people move from one-shot query answers, people want to converse with systems for data exploration. And so therefore, developing benchmarks for conversational systems is even like, you know, a step further in terms of complexity, because now the models that you trained using, you know, natural language and SQL pairs would need to be actually trained through conversational real world workloads. And since we are just starting off with these kind of systems, I think there are further challenges in collecting these kind of workloads to be able to test whether you could actually use a system and converse with it and accurately get answers to these systems, right? Because that's the basic aspect of natural language systems is that people are skeptical about accepting the answer that you get unless you have some kind of provenance or some kind of reliability built into it, which usually comes by when the system gets back an answer, you need to express what is the answer that you got back. So there's a reverse problem also, that you need to have a natural language generation explaining the result that you got so that people can actually believe that the system has actually understood the question. So I think in the real world, this whole loop and the challenges in getting how people would actually learn to interact with these systems are I think the major challenges here.
Yeah, I mean, you touched upon another dimension of, because all these benchmarks so far, they are pretty kind of static, maybe not for exploratory queries. And yeah, for your case and several other more exploratory querying type of workloads, that's also an open question. Any follow-ups, questions from the room to these answers?
But one thought just struck me as we were talking on motives for, I think we researchers and engineers have much stronger incentives rather than motive, have much stronger incentive to make something that performs better against benchmark X than to make a better benchmark. And yeah, I think we kind of get that we get that investment wrong, but you can see how that happens, right? It's like it's much sexier to make something that goes really fast against TCPH than to make the new version of it.
Yes, exactly. We actually we joke about it, you know, within our company, our team, about like sometimes the research community is looking at, or people in general are looking for your keys under the street light, right? So it's like, you know, there's so much of a vast area of darkness that people are not looking at, because that's like the street light is only like the lamp is only covering this small area. That's where the benchmark is covering, right? That's what people really optimize for. But there are many other things, string, columns, collations, or UDF performance. All these other things are not really covered very well by any existing benchmark.
Thank you. Are there any other follow-ups, or should we move to our next question?
Well, we have one more follow-up.
Perfect. Yeah.
Just a thought. So when we have all these benchmarks, could it be argued that we need to say that you need to clear a test suite before you're valid for a specific benchmark, perhaps?
So you might be fast, but incorrect. Yeah, I think yeah, it's kind of it's assumed, isn't it, that if you're posting a good benchmark score, that the algorithm is correct. But yeah, it does make you wonder how often a good benchmark's claimed that would fail correctness. Yeah.
Yeah, I mean, I guess, yeah, Tillman would know this better, but like for reporting on TPC site and so on, you need to show that your answers are correct, right, to the queries.
Yes, so there is basically audit, but actually, say for example, for TPC benchmarks, the audit will be on smaller scale factors. So if in larger scale factors, you might actually be wrong, and that's been happening in the past.
Okay, yeah, good point. Any other questions? I also checking online, but yeah, I haven't seen questions there yet.
No more here, or there is one more.
Okay, good.
Relating to the first questions, so I think there are two purposes of the test. The one is for the competitions in the way like benchmarking. The other is the purpose of the regression test. And I'm working with some companies. We presented in the first talk in this workshop. And actually the treasure data is cloud companies. And every day we receive is 2 million queries per day. And actually we need to efficiently make a test in the way like to workload compressions. So as the Zhang Yang said, that there's a great trade-offs between the speed of the test and the coverage of the test. And how do you trade-offs? How do you handle the trade-offs between the speed of the test and the coverage of the test?
So I can take a crack at it. So the way we look at it is sort of a combination of logical reasoning about what the test is about, as well as more automated reasoning about test coverage. So the way we check, like we have a way to check, for example, how frequently is a feature used in production. How often are combinations of feature used in production, because that's also cross-feature testing is another area where there tends to be problems. And thirdly, how often is an area what we call lightning rod, which means this is an area where there are constantly bugs. So that probably means that component was poorly implemented, or it was just a complex component that has a lot of issues, right? So when we select tests, we would, when we write tests, when we organize tests, there will be, metadata or labeling to say like this test is covering so and so area, right? So that's the first round of filtering to use to decide on what is the test about, or should I even be bothering with this test? But after that, you want to kind of based on the feature you're trying to test and based on the actual coverage of features in production, you try to identify the tests that are most return on investment to run. Right? That's kind of a way to achieve this, and there's going to be a budget, right? At any given stage of a test pipeline, you have a budget to say, I can run for 20 minutes for I don't know, like 20 nodes to run this test, right? And that based on that, we can figure out what subset of test to run.
But yeah, it is. I think it's a key thing. Actually, I was kind of preempting what was going to be my answer to what I think the next question on areas to focus on in research. But that you might call it testing productivity, right? I mean, we've talked a bit about how long it takes for the developer to get the test results back, which of course is very important. And there's another, but the flip side of the same coin is how expensive is it to run those tests, both in terms of like what's your AWS bill, and also, you know, even just how much electricity are you consuming and carbon are you putting in the atmosphere. And we were talking, Sebastian and I were talking just before this session, and just wondering, I haven't seen any data on this, but what percentage of all of the AWS and Azure and other compute is spent running tests? And I bet it's, you know, at least single digit percentage, maybe 10%. I've got no idea, but I suspect it's a lot. And I suspect a lot of it is pointless. In fact, I suspect 99% of it is pointless. We did something a while ago where we just started doing some analysis of all the tests we ran, which tests never fail in isolation, right? So if test A doesn't ever fail when test B doesn't also fail, it's probably not telling you very much, right? So it might, now maybe it runs quicker so that it's got some value in your pipeline, but generally trying to, I think everyone hates removing tests because it's scary, right? I have that test. It provides some kind of coverage, I think, probably, at least I can't be sure that it doesn't. And so I'm not going to turn it off. And so, yeah, we were just chatting out, just wondering what's the carbon footprint of all the pointless tests that get run every time someone creates a pull request.
Thanks. So yeah, that's another interesting dimension to consider. So actually, like if there are no follow-up questions, I want to, in the interest of time, because we technically had 3 more questions left, but one of them I think it's kind of indirectly discussed, and I want to merge the last 2 questions and ask basically, what would be your advice to the academics, like either in terms of, you know, how to educate the next generation of students so that they have maybe a better skill set when it comes to, you know, writing tests or doing more methodological testing and benchmarking in the real world. So this is like more the educational aspect of it. And the second dimension is, what would you recommend in terms of the promising research areas on this topic? And you can answer like either or based on your preference. So, yeah.
Actually, I feel that the universities nowadays do not really teach a lot about testing. Well, for example, the database courses, right? When nobody teaches how to test the database systems. Well, Chuck Andy's course, right? The CMU DB course. Well, yeah, he didn't really teach anything about how to test a database system. And I also believe that's okay in the universities where a lot of students will just write some meaningless tests. Even for me, when I was a student, right, I just write a lot of wrote a lot of useless tests because I feel that if I do not write tests, I feel guilty, but but the problem here, that's why I just write a lot of meaningless tests. And students do not really, and the other problem here, that's why if you do not check the AWS build, you will never feel about, have a concept about so-called test productivity, right? So you will never care about, so how much time, what kind of test I need to write, and what kind of test I should not write, and what kind of test should be included in the per-commit test or sanity test, and what kind of test should be included, should not be included in such kind of test cases. So I think we're in for me, I think where university should definitely teach in Davis modules, where the professor should definitely teach the students about test cases, how to write perfect test cases. And the problem here, that's where a lot of students, when we mention the test, a lot of students think that it's just about writing some test cases, just write about some unit test, or just write something about end-to-end test, but but testing a company, or especially a database company, it's nothing to do with, well, I mean, it's just writing such kind of test case is just a very small portion of the entire testing framework, right? So I believe that's what the university should not, I mean, as a professor, they should not just tell the students, okay, just write some test cases. They should teach them more, more than that.
Yeah, I think it's a lot broader than just database testing, right? I mean, I think it's just for software engineering in general. I mean, if you're doing it properly, you're spending maybe the same amount of time writing test code as code that's being tested, and actually probably more. I think it's if you look at that, what software engineering really involves, it's an awful lot of testing and it's an awful lot of debugging, much more than writing code, right? This stuff is just not, in my experience anyway, it's just not taught until you go and get your first job, and then you start learning it the hard way. We talked about the thing just before about not putting timeouts in tests. There are fairly straightforward kind of best practices that could be taught, and I think aren't.
Yeah, so I very much agree. I want to add that we never really teach people how to write tests and when to write what kind of tests, right? So there are unit testing, integration testing, regression testing, right? And then there's workload testing, and then you go to benchmarking and all these things. And at what level of your change should you add unit testing, for example? That's something that's takes time to kind of learn from others and form the best practices, because test-driven development is a very useful paradigm in some cases, especially that will help you. By enforcing unit testing, for example, I will actually enforce you to have modular design in your code. So I think these are very important things to teach students in college. Regarding the topic of key research areas, I haven't thought about it for too much, but I'll throw a couple ideas out there. One is with systems that are running as services these days, it's one thing that I've seen with testing frameworks is that these are tools or infrastructure that sit outside of the database, right? So they interact with the database from a client perspective. They're essentially some sort of scripts, or some clients, especially regression testing and these benchmark testing, they would send the query to the database through JDBC or DBC or whatever clients, and then they interact with that way. But one very interesting area is how to build a system that can self-test itself, especially if the system is running as a service. That's one aspect. The other aspect of intuition with the database itself is how can the test system leverage information about the database system, right? For example, during query compilation, we have a lot more information than at the semantic level, like when you have the query text. So if you have a framework, for example, that permutes the query, that does query generation, right? There are a lot more things you can do when you are working on top of a parse tree or some other tree representation in the query compiler, as opposed to manipulating a SQL text representation, right? So these are very, very interesting areas that at least I haven't seen a lot of kind of integration work, as opposed to something that just works on top of the database. The other thing I want to point out is cross-feature testing. At least this is a big problem for us. And as we get more and more feature to the database, there's a exponentially growing kind of dimension to be tested, right? I think you mentioned some of this earlier regarding hardware types, but there are many different things. For example, when you add, you usually might have a table, but later on you might add materialized views. Later on, you might add other kind of external table formats, and you used to have Parquet format. Now, let's say you added Avro, and then you added this and that format. All these things constitute a huge matrix, and how to build a system that will allow the developer to focus on write the test specifically for that feature, for the feature they're developing, right? So that they don't actually have to learn about every single other feature in the database, that they have to go and write a specific cross-feature test for his feature with every other feature, right? So that is a very, very important aspect of a testing infrastructure to allow the development team to scale. Yeah, I'll just start with these two ideas.
Thanks. Anything to add?
Yeah, so maybe from an academic point of view, so what's, like you say, there's a lot of best practices in industries, and how can we basically give them to the students? So other than sending them to internships, which we do, right?
Well, I'm not sure there is that much best practices actually happening in the industry, which is like part of the problem, right? I think, but I think one can imagine. I think one can imagine putting together at least one or two courses as part of a degree on testing. We talked about when you write unit tests, when you need system tests, fuzzing. There's a lot of stuff out there that is kind of quite foundational to being a good computer scientist or a good software engineer. And at least in my experience, we're sort of left to discover that ourselves. And I think it could be accelerated by being taught slightly more formally.
Yeah, I agree to that aspect. I remember, like, when I was in grad school, there wasn't much emphasis in the academia on actually testing courses themselves. So I actually took a course by Atif Memon, who is quite known in this field and now is working with the industry also in the field of testing. And so, formal courses which generally talk about testing, not necessarily like database testing, but tests are in terms of how much of workload coverage is there, how much of code coverage is there, how much of feature coverage is there, and what happens when you add new features. Do your older tests still run, and how does that affect your testing regimen, and what is the pattern and cycle that needs to be followed. I think more formal education in terms of courses at in the academia are very helpful, and I think that course that I took was quite helpful in understanding these concepts of coverage of how one should actually go about testing a website as opposed to testing a database, as opposed to testing a cloud-based service. So these are certain distinctions, and as we move forward in time, different technologies are becoming more important in terms of how the industry is progressing. So I think keeping those courses up to date and having sort of collaborations with the industry, with these professors who are teaching these testing courses, would actually, in fact, benefit the students.
So, yeah, because following up on the what the best practices are that are out there being used, I'm just reminded of a lot of what goes on out there. I think would be very shocking to everybody in this room. I give one anecdote of I was having a conversation with somebody recently who was working in it's just IT systems in hospitals, right? Rolling out modernizing hospital systems, and they've got their staging area, and they go and they run some tests, and they go into production, and they were talking about their test scripts, and I was just sort of curious as to how this all works. And so your test scripts are these, is it PyTest or are you running a Selenium or something? What do you write the test scripts in? And they said, oh no, Microsoft Word. And the test scripts are just like steps of things that a human does these steps and says, yeah, okay, that seems to be good. Right now we'll go from staging into production. And this person, and then they gave the story of they had like 100 different steps, and this poor person got one of them wrong because they're a human, and then this was deployed badly into production. So the good news in terms of the wider sort of training up the wider in industry is the bar is low. It's not going to be hard to improve.
Yeah, thanks for that encouragement. Yeah, we are. We are officially done with the panel, but like any last thoughts from anyone? Otherwise, yeah, I want to thank yeah, all of you once again, like for being a panelist in this panel. I think like this was a great way to close up this year's DB test. Yeah, thank you very much for everyone attending, presenting, asking questions. Yeah. And yeah, thank you very much, Tilman, for helping us on site because neither of us could travel this time around. So yeah, hope to see you in 2 years in another DP test, this time in person, hopefully. Yeah.
Thanks, Pinar. Thanks for organizing and inviting. Thanks.
Thank you.
So also thanks from here for organizing this nice program. I think it was really nice and worked out much better than I expected in terms of also participation. We still are not alone here, so this is nice, and we still are discussing. So this is better than other workshops that I attended. So thanks a lot, Pinar and Manuel, and yeah, thanks to our panelists.
Thank you. Thanks.
Thank you.
Thanks.
Take care, everyone.